WALL-E is comprised of 13 major components. Let's begin with mobility. 2 DC motors connected to a motor controller, and with the help of an omnidirectional wheel, WALL-E is able to move in any direction. Although the use of DC motors restricts the speed and weight of WALL-E, it is perfect for a smaller scale robot used for future development and planning. WALL-E has ultrasonic vision, avoiding possible collisions and safety hazards. To achieve full use of the ultrasonic vision, the head of WALL-E must be able to rotate. Thus we use 2 microservers, one with 180 degrees of freedom and one with 90 degrees of freedom, allowing the head to move left and right along with up and down. WALL-E also comes equipped with the LCD display, which shows the distance from a possible collision. For communication between the robot, WALL-E has been equipped with an infrared transceiver and microphone/speaker, all connected to a soundboard processing all the information collected. All the components are regulated and controlled through 2 microcontrollers, Arduino, and powered by a lithium-ion battery. Also, the use of a voltage controller is necessary, which is used to split the power and lower the voltage consumed by individual components to avoid short-circuiting. Finally, WALL-E is built on 3 layers of wood with 3D printed PLC chassis to hold individual parts. Furthermore, for future development, we have created the ARM, an essential feature of WALL-E.
The ARM is devised of 7 essential components. The entire structure of the ARM is comprised of a plastic chassis that supports 5 DC motors that control specific parts of the ARM. One motor is secured to the base of the chassis that allows the ARM to rotate left and right. 2 other motors are directly located right above, allowing the ARM to move up and down. Likewise, 2 more motors are also specifically dedicated to the crank component of the ARM that allows it to rotate left and right, as well as opening and closing. All these motors are directly connected to an Arduino Mega board, which is preloaded with code that allows the ARM to function. Now, how does the ARM magically move when the Wii remote moves? Well, this is a result of using the accelerometer within the remote as a mapping system. The remote utilizes an initial inertial frame as a reference position, and any movement that displaces it from that initial state is recorded as an anomaly within the code that can be translated into a corresponding movement, allowing the ARM to reenact human interactions.
Oh, hey there. So, what is the evolution of WALL-E? Robotics is a field of research that has allowed mankind to excel in many aspects, from functioning as prosthetic limbs to deep space exploration. Robots have shaped the world we live in today and now prove to be an essential asset. Although some might ask, what is a robot? Does a robot need to have mechanical legs, arms, or even a face? Well, the answer is no. A robot is simply a machine capable of carrying out a complex series of actions automatically, especially one programmable by a computer. Robotics is a field of research that will constantly continue to grow. The need for robotics with specific functionalities to perform precise tasks will never cease to exist. Likewise, robots are a means of simplifying physically demanding jobs. For example, robots now solely operate mass production of many factories that exist nowadays. Conveyor belts, automatic welding, packaging machines are all great applications of robotics being used as a means of simplifying and consuming work efficiently. You must be asking yourself, what is all this leading up to? Well, have you ever heard of artificial intelligence? Yup, we're bringing it to life. Let's begin with what a robot is all about before we get into complex data strings and coding and structures of artificial intelligence.
WALL-E is comprised of many complex components that allow him to fulfill such seemingly simple tasks, ranging from unidirectional wheels to voice recognition, as well as instantaneous material analysis. Is WALL-E really as clueless as we think? What if I told you that WALL-E is actually just as smart as your average physics teacher? If not more intelligent, actually. WALL-E's ability to comprehend physics concepts such as forces, dynamics, behaviors of light waves, and gravitational fields is far beyond most people. An example being the use of ultrasonic lenses that can not only be used as a means of collision detection, but also be used as a means of depth perception within solid objects, as well as in medical practices as doing X-ray scans. We chose to recreate WALL-E as a means of showing how physics is essential in allowing robotics to have usable and meaningful applications in real-life scenarios.
The study of motion can be divided into both kinematics and dynamics. Direct kinematics refers to the calculation of position effectors, orientation, velocity, and acceleration when the corresponding joint values are known. Inverse kinematics refers to the opposite case, in which required joint values are calculated for given end effector values, as done in path planning, for example. Some special aspects of kinematics include different possibilities of performing the same movement, collision avoidance, and singularity kinematics. Methods from the field of dynamics are used to study the effect of forces on these movements. Direct dynamics refers to the calculations of acceleration in the robot once the applied forces are known. Direct dynamics is used in computer simulations of the robot. Inverse dynamics refers to the calculation of the actuator forces necessary to create prescribed end effector acceleration. This information can be used to improve the control algorithm of a robot. In each area mentioned above, researchers strive to develop new concepts and strategies, improve existing ones, and improve the interaction between these areas. To do this, criteria for optimal performance and ways to optimize design, structure, and control of robots must be developed and implemented. Gears, wheels, motors. When used in conjunction, these components can be used to create elaborate robotic devices with endless capabilities. Even better, companies like LEGO have taken robotics out of the confines of high-tech laboratories and made them available to anyone that desired to create and learn. A mandatory mechanism required to allow most man-made creations to move are motors. It converts electrical energy into mechanical energy and has the ability to power and move an object if connected to a wheel. The motors used within robots vary in size and capabilities. When used in a robotic system, most electric motors operate through the interaction between the motor's electromagnetic field and winding currents. This is how force is generated within the mechanism. Electric motors can also function as a means of converting electrical energy from mechanical energy through braking or coming to a stop. This application of motors is used within most robots as a means of adding sensitivity to the robot so it can be driven with more precision. Electric motors produce torque. This torque is very different from magnetic solenoids and loudspeakers, as they convert electricity into motion.